we talk about language models and these tools and kind of their capabilities, but a lot of it is kind of some guidelines or even some warnings about watch out for hallucinations. You have to have a good understanding of coding in the first place in order to effectively use these tools. You might be able to use them, get an output, but is that output correct?
You are listening to Stories from the Hackery, a podcast about the students, alumni, and community members that continue to shape Nashville Software School. NSS is the nation's first nonprofit coding bootcamp, where anyone with aptitude and motivation can gain the skills needed for a career in tech. For more information, visit NashvilleSoftwareSchool.com.
Welcome to another episode of Stories from the Hackery, where we're going to continue talking a little bit about generative AI. And I'm John Wark. I'm the founder and CEO of Nashville Software School, where for the last 12 years, we've been helping adults gain the skills to become job ready in technical careers in software development, data analytics, data science, and others. I've been in the tech world for about 50 years. I started programming on mainframe computers back in 1971, done a number of startups, including the software school. And I've been fascinated here recently by the rise of generative AI in the last 18 months or so. We've talked already on our podcast about that, and we're going to talk some more about that this morning with Michael Holloway, who's our lead instructor for data analytics and data science. Michael, could you introduce yourself to everybody?
Absolutely, yeah. Thanks, John. I'm Michael Holloway. I'm the lead instructor for the data programs at Nashville Software School. I've been with the school since 2019 when I started teaching the data science boot camp, and I'm teaching my fifth data science cohort right now. In 2021, I took over as the lead instructor for the all of our data programs at Nashville Software School. My background is in mathematics, and that from studying mathematics and in the last decade or so, just the rise of data and data science and machine learning models. I got interested in learning more about that subject, and so that led me to where I am now, teaching data science and heading up our data programs at the school.
Yeah, and so Michael, you've got an overview of what's been going on both in data analytics and data science, which are yes, relatively distinct fields, but they're really also on a continuum of skills related to understanding, analyzing, making sense out of, answering questions with data, right? And
Absolutely.
so you've been really the entire time at NSS, you've been teaching topics that come from the artificial intelligence playbook, particularly this things around natural language processing and machine learning. And here in the last, 15, 18 months, have like all of us been watching what's going on with this generative AI stuff, ChatGPT and the similar types of tools, how they can be used in support of the work of data analysts and data scientists, where they help, maybe where they don't. And we've seen a lot of evolution even in the last 15, 18 months.
Absolutely. Yeah. It's gone from, generative AI was something where, oh, look, you can make these fun images, you can generate new faces. That's fun. That's interesting. But where's the practical use to all of a sudden this stuff is all over the place, and it's going to really transform a lot of the ways that a lot of people are doing work.
Right. And so what we want to, I think, talk about today a little bit is what are those ways maybe that these tools, this technology is transforming the nature of both learning and doing data analytics work and data science work. There'll be times where we probably use data analytics as an umbrella term, but there's times where we'll strike a distinction between data science work and data analytics work. But how is this impacting the learning? What's going on directionally? What's the evolution we see happening? And just like we have discussed on other podcasts, the impact it's having on software development, we'll talk some about, how it's impacting the work that we're doing in analytics and data science, some of which is coding related, just like software developers, but also where it doesn't really have an effect, doesn't really help productivity wise. And we'll talk about some of the capabilities and restrictions and risks associated with using these tools. So maybe Michael, let's start maybe with similarities. I think that's a good place to start. Let's start with, for a lot of analytic tasks, I think there are similarities. So let's talk to us a little bit about, where you see the similarities of where we can use generative AI tools in doing analytics work.
Absolutely, yeah. With analytics work, with data science work, when you're working with data, a lot of times you are writing code. That might be if you're using Python, if you're using R for data cleaning, data transformation. That is code that you're writing. It can involve working with SQL. If you're working with databases and you're writing queries to retrieve the data, you're writing code there. It can even be working with tools like Excel, where you're writing formulas. Power BI, if you're trying to write DAX formulas. All of that is writing code. And these language models, they're really good at generating text, and they're really, really good at generating highly structured text. So some of the earliest applications of these language models have been for generating code, because it is very predictable, as a specific structure it has to follow. And so that, because a lot of analytics work involves writing code, then these tools can be incredibly helpful for that kind of work.
Well, which, the fact that these tools can generate code as a form of highly structured text with, a lot of times predictable patterns associated with, particularly relatively small units of code, that generates some predictable concerns, some of which have been sort of headline news kinds of things, right? Well, it generates code, so therefore we won't have to learn how to write code anymore, which, I think we found probably is not true. We'll come back to that one. This is going to put analysts out of business because it can generate all the code that they generate. We don't think that one's true. That one's definitely not true. We'll come back to that. But I think, and there was a lot of, I think, hysteria around that kind of stuff early on. I think we're moving away from that hysteria relative to, our jobs being at risk, but we'll talk about that some more. And more to a view of these things as possibly a productivity aid, a sidekick, a junior programmer that can generate code for us while we think about solving the bigger problem.
Yep.
So, and I think that's part of what we're going to explore a little bit. But that's a way in which, again, there's real similarities, I think, between software development, software developer jobs, data analyst, data science jobs. But I think there are differences because, the work that data analysts and data scientists do, are different. They take different forms. There are different skills. There are typically different kinds of problems we solve. So maybe give me a little bit of a taste of what you see as some of the key differences.
Yeah. So, I said, a lot of data work involves writing code, but the writing code that's not the end of the story. That when you're working with data, the goal is, I've got a data set. Maybe I have a question I'm trying to answer. I'm trying to, get some insights, maybe help somebody to make better decisions. And so, the insights, being able to go beyond just I wrote some code and got a result, but being able to answer, the so what. So what can I do with this result? Why is it relevant? How is this useful? How does that help me answer the questions I'm after? I feel like that's really where the real work of an analyst comes in. It's not just I wrote some code, it ran, I got a result, I'm done. That's kind of the starting point. I got the result. Now, what can I do with that? Where do I go from here? What additional questions do I need to ask? So that can often analytics work is a very iterative process. So you'll write some code, get a result that will maybe spawn a dozen new questions. And so looking at the initial output, now what should I ask next? What should I calculate next? What sort of plot should I make next? And then you can write some code for that. But then you have to have kind of the big picture. How is this useful? What do I need to report back in terms of my findings when working with this data set? So it's really those insights are the important job of an analyst, and so it's beyond just the coding part.
Right. So there's this exploratory, if you will, or this sort of iterative. Yeah, it's this. You said iterative. This iterative exploration of the overall question you're trying to get answered in the context of the data set, or a lot of times multiple data sets, right, that you're working with, or that you're combining to get the data that you want to study. So there's a design aspect, there's a planning aspect, although it's not something you can plot the whole plan out ahead of time. It's something where you're discovering the plan as you go.
Absolutely.
And I think one of the things we know about LLM technologies is they're not very good at that kind of reasoning. Maybe we could just talk about that a little bit. So, talk to me a little bit about what fundamentally is an LLM, right? What does it do? And so what is, and that, what is it good at, or why is it good at what we've already said it is at generating structured text, right? And what is it not so good at, given the nature of how that technology works?
Yeah. So an LLM is really just a tool that is very good at predicting the next word. So it's very good at filling in the blank, or I give it the start of a sentence, and it can tell me what is likely to follow next. So some people say it's autocomplete on steroids. That's the way some people describe it. It's a little bit more than that. But basically, I give it the start of a sentence, or with LLMs, really, you give it what's called a prompt. So you can ask it a question, or direct it to do something. You might direct it to write some code so that to import my data set, and then it can come back with a response, and that response is based on the data that it has been trained on. So these LLMs are trained on a vast quantity of textual data, coming often from the internet. It might be coming from sites like GitHub, where there's a lot of just kind of code sitting out there. And so by seeing this vast quantity of text and getting an idea about what words tend to go with what words, it can become very good at that next word prediction task, and then from there it can generate plausible sounding text. And that I guess that's the key thing when you're working with an LLM is it's generating plausible sounding text. They're not designed necessarily to give you factual text, or there's no internal mechanism to check that what it's producing is actually correct within the LLM itself. But it's just saying, I think this sounds right. This sounds like a good response to the question that you've asked me, or for the directions that you've given to me.
So it depended on the quality of the training data relative to the question you're asking it. But yeah, so I mean, I've heard it characterized as, they're basically a probability machine, right? It's a, and for certain types of structured things, or questions where there's lots of data in the training set that it's been trained on relevant to the question being asked, it can give you a better, and better response based on the relevance of the training set to the question you're asking.
Yeah, and when it comes to data analytics, like if you're working with the pandas library, so a very common tool for data analytics or data science work is using pandas in part of the Python library. And there are a lot of examples of how to work with pandas, out there that these language models have been trained on. There are some typical patterns, very common patterns that come up over and over and over, across different data sets. And so these LLMs have seen a lot of these common patterns over and over again. And so when you ask it to help you write your code to work with your data set, it can kind of pull from these patterns and help you generate some code that may work. I guess one key thing with these LLMs is that a lot of times they'll generate code that's not exactly right. And so it can get you kind of started or get you something close a lot of times. Sometimes it'll be, perfectly fine. It'll run, it'll produce what you want. But a lot of times you might try to run it. It might give you an error. It might give you output different from what you really wanted. And so you have to go in and kind of tweak that code so that it applies in your particular case or for your particular problem.
And so I guess one of the important aspects of what you just said is the tool doesn't know whether the code it generated is relevant or appropriate or accurate. Somebody else has to determine that, which means somebody still has to know what accurate code would look like and what an accurate result would be, and has to test it, right?
Exactly. Yeah. That's that last part that you said, an accurate result is that's one area where you're not replacing analysts anytime soon, because even if it gives you code that is error free, it runs, it produces a result. A lot of times, like one of the things that we teach students in the boot camp, where we have to emphasize a lot is, the code ran, you got a result, but now think about that result. Does that result make sense? Does something look off about it? And if so, what are potential sources? Why might that code, why might that result be off? So, if you're working with data from the census, we have a lot of projects where students are pulling from the census. And one of the things that the census does is, if you're looking, let's say, by census tract or by zip code, they might be able to report median income for a lot of different census tracts, but there might be some census tracts where, for whatever reason, they can't report a number. And what the census usually does is they'll put in like a negative 9999 in for median income or population or whatever it is. And so if you're working with data you pulled from the census and you ask it to tell you the min and max income and across the different zip codes you're looking at, you'll get code, it'll run, but you have to look at that and say, oh, wait a minute, that number doesn't make any sense. It shouldn't be negative. It really shouldn't be that negative either. And so saying, okay, well, why why am I getting that result that is off? What's the source of that? What's the cause of that? And being able to track that down, that often involves knowing information external to the data set. So, internally within the data set, we can say, hey, that looks weird. Something's not right about that, but we wouldn't be able to answer, why is it wrong? So we have to have some external knowledge about, oh, this is how the census normally encodes these variables. And so if I'm working with this data, I need to be on alert for that. I need to be looking out for that. And I need to have a plan to kind of correct that issue, or at least not let these numbers, kind of creep into the rest of the analysis downstream tasks that I'm working on.
We always talk about, when we talk about data analytics and data science, the criticality of understanding your data. It seems to me that what you've just given us is a great example of understanding your data. Why are there these strange values? Well, because that's the way we encode something to indicate that we don't have a value for that. Whatever, but it is part of that. You called it that broader contextual knowledge, right? Of your data. What is this data? And understanding, I guess, the problem domain, right? Mm-hmm. And I know when we talk about data science and data analytics work, we have to talk about this sort of Venn diagram, if you will. It's not really a Venn diagram in a mathematical sense, but it's three circles that overlap. So what the heck? But we talk about this Venn diagram of, I guess, knowledge and skills that a good data analyst or data scientist has to have. And it seems to me that knowledge of the data, right? That sort of contextual, or that domain expertise, right? I have expertise in this public health data, right? That allows me to analyze COVID disease trends and decide whether we have a problem or not, right? Or I understand census data and what it means, what it doesn't mean, right? In a broad contextual way. I understand my problem domain of supply chain management. I'm in a logistics firm, right? That's one of the areas that these tools, I don't believe, have an understanding today. Certainly not the general purpose sort of public LLMs like a ChatGPT or whatever, Claude, whatever, aren't going to know those things that are local to your data, your company, your industry, right?
Absolutely. Yeah. That domain expertise, knowing what do we care about? What should we care about in this particular context? Having an understanding of the business and what are relevant metrics to the business is critical. So these LLMs could give you code, to generate common plots, do kind of common summary statistics. You can even help, to some degree in the interpretation of those, but you don't have that deeper understanding, that deeper contextual information to really deliver the value from the work that you're doing.
If you're enjoying this episode of Stories from the Hackery, subscribe to the show on your preferred streaming platform so that you're notified when new episodes are released. Support NSS in their mission to create opportunities for individuals to gain skills for high-paying tech careers who are financially disadvantaged or from underrepresented groups in tech. Visit nashss.com/give to donate to the scholarship fund and learn more about other volunteer opportunities with Nashville Software School. And now, back to our conversation with John Wark and Michael Holloway.
If we sort of think about that Venn diagram a little bit more, where else in the context of those three circles, right, where one of them is coding software development skills, right? And we've alluded to that part of it a little bit already, at least. You've actually talked a little bit about the sort of analytical reasoning skills, the sort of mathematical reasoning or numerical reasoning skills.
Yes.
You've hit it. You've mentioned that before. We haven't said that that's another one of those three circles, though.
Mm-hmm.
And then we've talked sort of about I don't know, domain expertise or whatever is the third circle. Talk to me a little bit more about areas where the tools can help support us, maybe in those three areas where they don't help us today, right? And things where there's, there may be risks with these tools relative to, one or more of those areas.
Absolutely. Yeah. So I think, we've talked extensively about one of those circles. So one of those circles is the coding skills, sometimes hacking or coding skills. And so I need to generate a snippet of code in Python to do this particular cleaning task or to generate this particular type of plot. LLMs are really good at that part, at giving you snippets of code, maybe not, maybe not the whole workflow, but if you break it down into smaller pieces, LLM can help you, kind of get those small pieces, and then you can put those together. The domain expertise, that's the area where the LLMs really struggle, because that's not what they're designed for. It's kind of impossible. It's not within their training data to have that context. And so that's where you need you need a human in the loop to do that part. The third circle, that kind of mathematical or statistical reasoning, that's another one where LLMs can help, but you have to be cautious. So, doing analytical work or data science work, that might involve doing some descriptive statistics. So, calculating, averages, calculating ranges, that kind of thing. If you're working, if you're a data scientist, you might be doing some statistical analysis or working with machine learning models. And so you need some knowledge about how those things work and how to interpret them. And that's an area where LLMs can be helpful because they've been trained on the internet essentially, and so they have in their training data a lot of information about how to do descriptive statistics, how to interpret these things. And so you can ask them not just code questions. You can say, not just help me write some code to generate an average or generate an average by group, but you could ask things like, in what cases should I be using the mean or the median, or what things should I be looking out for? If you're working with different machine learning models, you could say, well, what are the strengths and weaknesses of working with a random forest versus a linear regression model? You can ask it those conceptual questions, and it can often give you back good responses to those questions. And so you can use them. They're one thing you have to be extremely cautious about with LLMs is that they are not a substitute for something like Google, because it is just generating plausible text, and so it's not always reliable what it's going to return. So if you're trying to find something factual, you're better off going to Wikipedia, or if you're interested in a particular type of machine learning model, going out and finding some notes on that is going to be definitely more reliable. So if you're asking these conceptual questions, you have to do it with caution and kind of verify any outputs that the model produces. But as long as you go in with the mindset of I need to, I can listen to the results, but I need to verify any information that comes out, then I think they're incredibly useful, and they can almost serve as kind of a tutor or a guide in some sense, if you do prompt engineering. So prompt engineering is a way that you can essentially change the way that you're asking the model to do something. So you can tell it, I want you to be my machine learning tutor. I'm trying to learn some basic concepts about machine learning, and so I need you to guide me in working with my data set. It will change how the model responds to you. And so through prompt engineering, you can use these LLMs to really help you get a good understanding of the models that you're working with, limitations, things that you need to consider when working with these models. So that's an area I think that those two are ones that the LLMs can really be helpful.
So let me maybe recap or summarize a couple things you just said. Last thing you said was prompt engineering is all about how do you ask the LLM the questions you want to ask it, right? It's basically a way, as I understand it, it's a way to impact the output of the probability model. You're basically putting your thumb on the scale saying, think about this more, right? Because you're telling it to sort of think in a certain way, or assume a certain set of knowledge that you might have, or there's all kinds, and there's many different prompt engineering techniques. It seems like every week a new one gets, but it would be sort of like talking to your tutor or talking to your mentor and saying, I understand this, I understand this, I understand this, but I need some help with this. So as opposed to just saying, I need help with this without any of that other context. So another way to think about it, it's a way to affect the context that the probability model has. And it seems pretty clear from all the work that people have done here over the last year that good prompt engineering skills can have a dramatic impact on the quality of the answer you're going to get from the LLM relative to the problem you're trying to solve. So there's a skill there to be cultivated, which we'll come back to, I think, when we talk about how this is impacting our classes. You also talked about something else I think was pretty important, that I want to come back to and see if you can give us a little bit more of an example. You talked about the importance of breaking a problem down into smaller and smaller pieces, right? Mm-hmm. Maybe starting with the big question you're trying to answer and then breaking it down into smaller and smaller pieces. And I think you said something alluding to the fact that for some of the things that has to be done in analytics work or data science work, some of these tools are better at helping us the smaller and more discrete the pieces are, right? And which is also maybe ties back to this sort of iterative exploration you talked about, where I'm carving up the process of getting to an answer into small pieces. I do a piece, I look at the results, that modifies what the next piece is. But can you give me an example of, breaking a big problem down into smaller problems and where these tools start to have some impact?
Yeah. So these models are they're not good at planning. Because they're designed as next word predictors. Basically, that's a very simplified view of it. And so, one of the projects that we've had our analytics students work on in the past is they've been working with data on scooters in Nashville. So these companies like Bird and Lime, where if you're walking around downtown, you're driving around downtown, you see these people all over the place on scooters. And so when these companies first started putting these scooters out there for people to rent, then Metro had to decide how are we going to respond to this? Like what rules and regulations are we going to have in place? And one big question was like, how many scooters do we really need? Like, how many scooters are we going to allow there to be out there, and where do they need to be located? And so our students were actually working with data, from these scooter companies on where these scooters were located, how they were being used, data on different scooter trips. So they had this, kind of vast data set on scooter usage patterns. And the question they were trying to answer was, how many scooters do we need? what is kind of the optimal number of scooters for Nashville? What is the optimal scooter density for Nashville? And so if you go to an LLM and you ask it, I got this data set, how many scooters do I need? It's not going to be able to answer that. It could potentially give you some ideas on directions to go in. But even then, it's probably not going to do a very good job. But if you were to think like an analyst and say, all right, what things do I need to consider with this problem? How many scooters are out there now? How many scooters are being used? What is typical usage throughout the week? How does typical usage throughout the week differ from on the weekends? So having these smaller problems that you could break it down into, and so those are going to kind of steer your analysis, based on answering these smaller questions, that can get you on the track to answer the big question. And where the LLM can come in is, if I've got my data set and I'm trying to figure out how many trips were there last weekend, and I'm trying to figure out the code to answer that question. That's something where I can ask the LLM, I'm trying to write some pandas code to answer this question. What will that look like? And it could come back and help you generate the code to answer that one kind of discrete question, and then whatever the follow-up question you might have, like, oh, is that usage pattern? What is the typical usage pattern on a weekend? I need some code for answering that. And so that's where an LLM can, through a tool like GitHub Copilot, it could do. GitHub Copilot is sort of autocomplete almost for code. So as if you're working within your IDE, if you're working within Visual Studio Code, as you are kind of typing out, if you write a comment, basically like, I want to look at average number of trips on Saturdays and Sundays, then it will come back with a suggestion of this is what the code for that might look like. And so by breaking it down into those steps, the language model can come in with useful suggestions on how to calculate that. But really, it's the analyst that's driving the process, because they have to be asking the right questions in the first place and taking those results and asking the right follow-up questions from there.
So that's the human in the loop element that you mentioned. That human in the loop is a phrase that we're starting to hear all the time now about AI. And that appears to be one of the best practices for using AIs for really any application, not just data analytics or software development. I know Ethan Mollick, who just published the book Co-Intelligence, one of his 4 principal rules is human in the loop. You got to have the human in the loop, because only they can analyze the output. Only they can make the choice of what technique to use. And it seems to me in that example of breaking the scooter problem down into smaller pieces, that's also an example of where I might be able to use it as a tutor for one of these pieces. Maybe I want to analyze how many extra scooters we need, because there's going to be a certain number of them in maintenance at any given point in time. So if I want to build sort of a machine learning or analytical statistical model for analyzing that, I might ask the tool what would be 3 different modeling techniques I could use to predict maintenance based on the data I've got. But ultimately, the analyst is going to have to make the choice over which technique to use. And that's, again, going to take some contextual understanding of the data and, in the context of the problem, the data, which is the right technique. Or pick 2 and compare the results, right? I mean, but again, the human in the loop is as I understand what you're saying, is going to have to be the one to control that.
That's right. Yeah. And what you're describing, that's another area where it is very important to have a human in the loop. So these things will generate an answer or response. But you don't want to just usually you don't want to just blindly follow the suggestion. And if you're doing, particularly any type of statistical analysis, or if you're applying different types of machine learning models, you really need the human expertise to make sure, like, have I met the assumptions? Is this actually applicable to my particular data set? Are there any maybe nuances that about the data, about the data, the way the data is collected, that is going to make this technique maybe not as applicable to my particular problem. And in my experience, I don't know if this is universally true, but in working with like ChatGPT in particular, I think it can be almost like too positive, or almost too much like a yes man sometimes, where if you say, oh, could I apply this in my particular context, then it will say, yeah, that seems like a good idea. You should do that. And so, having a human to kind of double check that reasoning, like, okay, I'm not overlooking something and I'm going to get nonsense results in trying to apply this particular technique is just super important. So that applies if you're doing statistical analysis, or any sort of system using an LLM. Often has a human in the loop or an expert in the loop to double check the responses and make sure that they're correct.
Yeah, because these tools, one thing they don't lack is self-confidence, right? I mean, so if you ask it about some statistical technique, as you said earlier, it can help you understand the concept. It can help you understand, but if you ask it for a specific reference you can look at to better explain, that's where we run into the hallucination problem. Now, as you said, they're not a substitute for using a search tool to look up exact references, right? Because we've all had the experience of asking these things a question and then saying, well, can you give me a reference on that? And have it give you a reference, right? Cite a paper, cite a book, cite a whatever, and then not be able to find that. And in fact, find out that it's made up. And then you come back to the tool and you say, that doesn't appear to be a valid reference. And the tool goes, oh yeah, you're right. It's probably not. I don't do that. That's the hallucination problem you hear about all the time with these tools. And we haven't totally figured out, at least again with the general purpose tools, haven't figured out how to fix that. Now, I should say, I guess, that some of the things we've talked about, that the general purpose tools, the ChatGPTs, the Claudes, the Gemini Pros, and whatever, can't do, there are ways to more narrowly train these tools or restrict them around, let's say, my organization's specific data, right? And there are techniques for doing that. I might do what's called fine-tune a model, start with an open source model. I might do something called retrieval augmented generation to, again, maybe take an open source model and then restrict it by specifically training it on my data. That goes beyond the kinds of things we're talking about here. And those are all things that take trained developers, trained analysts to do. So, and that's sort of an advanced, certainly today is an advanced skill. So we're not going to talk about that really, I think, in this podcast, although we've talked about maybe doing another podcast where we get into that stuff a little more. But I did want to throw that out so nobody jumps in here and says, "Oh, you can do that." It's like, well, okay, slow your roll. We're talking about here about getting people trained up to be job ready and exploring, what does job readiness mean in this changing world? So maybe we can switch over to that topic a little bit. I don't want to jump off any other things that maybe you want to talk about, but let's talk about, because we're seeing lots of trends with tools. We're seeing the new tools we can use, the ChatGPTs and the Claudes and whatever. We're seeing existing tools augmented. You talked about GitHub Copilot, right? Where I now can have in my code editor an advisor, right? Which is an LLM that I can use as a coach, or I can use this as an autocomplete sort of a tool. But I think some of our other analytics tools are getting those kinds of advisory capabilities built into them.
Yeah,
But
Power BI and Tableau are both now have or have announced at least these co-pilots where you can basically just describe in plain English, I want a dashboard to summarize sales for the last year, and it'll say, okay, I've here's the dashboard. You can ask it a question, or I need to write a formula in DAX to do this particular computation, and it can come back and have a formula that will oftentimes be correct. So it's not just code, but yeah, other types of tools have these.
And that's in a situation though where we've defined our data or our data model to those tools. Right?
Yes.
So again, my data analyst or my developer has to do that work ahead of time. So again, it's sort of a form of fine tuning, if you will, the tool, I guess. All right. Well, let's talk a little bit. Let's talk a little bit more about, how we're looking at evolving our training, the content of our classes, the training, that our students get, so that they are job ready in this evolving landscape. Because I think given what's happening, I think it is fair to say that we think that what the trained junior data analyst looks like 2 or 3 years from now is different than what they look like 2 or 3 years ago. And we're in this state of transition. So how are we responding to that at this point? Maybe we talk a little bit about both data analytics and data science programs. So maybe data analytics first.
Yeah. And in our data analytics program, at the moment, we're still big emphasis on you've got to learn the fundamentals of writing code, working with Python, and so from when we start those technologies, we tell students, stay away from those tools for generating code, because you've got to get the reps in so that when you're working with it, I've sort of described how Copilot can give you a code snippet, and it will often, a lot of times it'll be correct, it'll work. A lot of times you'll have to make some changes to it to make it apply in your particular case. And so if you don't have those reps in, if you don't have the background in, you're not going to be able to do that. You're going to get stuck. You won't know how to kind of debug the output there. And so we talk about language models and these tools and kind of their capabilities, but a lot of it is kind of some guidelines or even some warnings about watch out for hallucinations. You have to have a good understanding of coding in the first place in order to effectively use these tools. You might be able to use them, get an output, but is that output correct? Are you going to get an error? Is there something specific about your data where that code is not going to be applicable? And I think what it's done is it's sort of shown bright light on the fact that human element, that being able to interpret the results is the important part when it comes to analytics work. So what do I learn from this data? And so that it's always been an emphasis in the boot camp, but I think it's even more of an emphasis now. And I think as these tools get better and better, so these things are getting incorporated, as I mentioned, in tools like Power BI and Tableau, where you can basically ask your question with little or no knowledge of how to write the code, and you can get results out. But then that next step of, what do I do with this? What is the takeaway? What do I need to report back about my data is really becoming even more important. I think will become more important, or it maybe the fact that it is so important is going to get is going to be on display even more, where the coding part, maybe the kind of the barrier to entry is a little bit lower in terms of being able to write SQL code or Python code, because you have these sorts of assistants that can help you there.
But to become an effective human in the loop, if you will, the data analyst still has to have that skill.
Yes.
Right. The coding skill, the understanding how to test to make sure the output's valid, the understanding of how to look at the code generated and make sure it's not doing something nonsensical.
Absolutely. Yeah. At least at this point in time, it might change. I guess these tools are getting better, but for now, and I think for the time being, you definitely need that knowledge.
Yeah. And making the human judgments and understanding the data, sometimes we joke that 75-80% of the job of a data analyst is in sourcing, structuring, aggregating, and cleaning data. And it sounds like these tools, while they can help with it, because, for example, cleaning data takes writing some code that's going to go through and do something, but to understand what has to be done to clean it, to be able to give the tool the very detailed instructions that it takes to generate good code for that, the analysts are still going to have to understand that, and it feels like we're seeing that, right, with more and more. We see a lot of our grads going into data engineering jobs in support of analytics and data science. And I think like this is, that it's one of the drivers for that is that in the age of the LLM, the data even becomes more critical and understanding it and having it clean, right?
Yeah, if you're going to do these advanced analytics, if you're going to do machine learning, that sort of thing, you've got to have good, reliable data, and it's got to be cleaned. You've got to have the ETL step to get it in shape where you can then apply these techniques to it. I guess it's easy if the data is in good shape, but in the real world, it's not going to be in good shape.
Data's never in good shape. Yeah. So at least not for whatever it is the problem somebody just asked you to answer, right? Might be in great shape for some other question, but never the one you just got assigned. All right. So some of what my interpretation of some of what you're saying is at least related to data analytics. We are helping our students understand the strengths and limitations of these tools and how to use them, so that our grads, being job ready sounds like having the skills to be able to be the human in the loop, to still get good answers out of the analytics problem solving process.
Yeah.
So unless I've totally jumbled that and you want to correct me and fix it, maybe talk about data science a little bit. How's it different, if it is, relative to our data science program?
Yeah. In data science, a lot of what I just said still applies, because in data science, you're learning how to work with code, or doing analytics, or maybe predictive tasks, building models or doing statistical analysis, and so being the human in the loop to ensure that the code is correct, the results make sense, to do that data cleaning is very important. In data science, so another thing that has changed, over the last year is related to our machine learning and natural language processing unit. So machine learning is something that, since it's been included in the curriculum ever since the data science program started. So, working with predictive models primarily. So, we're in our current class. We're working on a project where we have data from 18-wheeler trucks, and we're trying to predict whether a breakdown is going to occur, in the next day or so that they can get some. If we can predict it ahead of time, that can save them a lot of money because they can get the truck worked on before it breaks down. And so, having some outcome that we're trying to predict, that's primarily been the type of model that we've been focused on. These LLMs are also types of models, but the goal of an LLM type of model is different from making predictions, or at least it's sort of making predictions in a different way. It's generating new things. So for predictive models, you have a data set and you're trying to predict an outcome. In some ways, the LLMs, you have an outcome and you're trying to predict the data. Essentially, I guess would be a simple way to put it. And so, we've incorporated a little bit more time spent on these generative models, where before they got mentioned, but we didn't really do too much with them. But with these generative models being all over the place and becoming more and more relevant, then that the amount of time that we spend talking about generative models has increased. We also have a natural language processing unit, so you learning to work with textual data, and that has kind of morphed with the rise of these large language models. So, but before it was, we focused a lot on kind of predictive, maybe text classification models, like is this positive sentiment or negative sentiment, that kind of maybe information extraction. So you have some text and you want to identify the entities in that text. Well, now, with large language models, kind of the rise of large language models, and people using these large language models within other applications, then we've incorporated some of that into the NLP unit of our data science boot camp. So talking about what is retrieval augmented generation, how does it work? What are the technologies around that? So learning about what is a vector database, how does it work? How is that part of the workflow of a retrieval augmented generation setup? So there, I would say there are some more dramatic changes related to kind of the shift in how people are working with data and doing machine learning, or the types of models that they are working with.
Yeah, because while machine learning models are different than the large language model are, the techniques do get used together in the sense that machine learning models are what's used to train a large language model. And so while most data scientists aren't going to be training an LLM, because a true at least what's called a foundation model, a large language model, the training of one of these things is a very long,
huge.
Tens or hundreds of millions of dollars of investment. Most of us are going to start with an LLM that's at least already partially trained, but now fine tuning it. And some of these other techniques, as you said, retrieval augmented generation, some of the techniques that we're teaching are very relevant to preparing a graduate from our data science program to be able to move into using a machine learning model to maybe help fine tune something, or to do retrieval augmented generation, or those kinds of things. So yeah, it's like we've got more applications for the skills that we're teaching than we used to have because of LLMs. So
yeah. And with these LLMs, if you're not a Google, if you're not an OpenAI, you're not going to be training one of these from scratch. But there are a lot of these open models out there. Hugging Face has essentially a repository of a lot of these pre-trained models that you can take and put within one of these systems, if you're doing retrieval augmented generation, you're going to be using a pre-trained model, or a lot of times you will. You can use a fine-tuned model. I guess you can make it more kind of elaborate, but quite often you'll be taking something kind of off the shelf, pre-trained, and incorporating that in there.
So in Hugging Face, which you've just mentioned, just in case people don't know, Hugging Face is basically, it's a website where you can find a lot of the open source, both open source LLMs, as well as large numbers of open source tools that I can use with these LLMs. So I can find tools to help me train them. I can find tools to help me implement retrieval augmented generation. So I can find tools like, LangChain or some of these kinds of things. So Hugging Face is sort of like, like we go to GitHub to find open source software libraries. Hugging Face is, among other things, positioning itself, I think, as a place to source open source generative AI tools and technologies, right? So,
exactly.
So, all right. So I think we've talked a little bit about strengths, weaknesses, risks of some of these LLM tools. We've talked about some of the ways we can use them effectively as a tutor, as an aid, as an eager code generating intern whose work needs to be double and triple checked. And we've talked a little bit about how we're shifting some of our training in both data analytics and data science to help make sure our graduates remain job ready with skills that are needed for the junior data scientist, the junior data analyst, who's leaving our program looking to get that first job on the data analytics, data science career path. And we've alluded to how these things continue to evolve, that there's more tools coming. Generative AI is evolving quickly. It's hard to tell what it'll look like in 2 or 3 years or 4 years. Sometimes it seems like it's hard to figure out what it's going to look like in 2 months. So, but it is something, I think it's something we're looking at, something we're trying to stay on top of. So, so I think for this episode of the podcast, it feels like we've kind of covered, a lot of the things, around the topic of how is data analytics, data science being impacted, and how are we evolving our classes to sort of stay up with that. Any last words from you, Michael, on any of this?
I'll just say it's exciting to see where these things are going. We've talked about this a lot, but the job of a data analyst or data scientist is not going away anytime soon. It's not going to be superseded. I think these tools are just highlighting, the critical role, the importance of the human in the system. So,
right, yeah, that sounds like a really good place to wrap up this episode of Stories from the Hackery. So, so thank you, Michael, for sharing all that information. This is fascinating stuff, and I'm looking forward to, our next podcast where we talk a little bit about, architectures for applications that integrate LLM or generative AI capabilities, and how to customize them to a particular context, a particular problem domain, a particular company's data, whatever. I think that'll be fascinating. So, but for today, thanks everybody for listening. Thank you, Michael, for the information, and signing off.
Thanks so much for listening. You can find the links mentioned in today's podcast in the show notes below. Hear more insights like these when you visit NashvilleSoftwareSchool.com.